Why do some highways last 25 years, while others start cracking in just 2? Why do brand new roads sometimes develop potholes after a single rainy season? Is it poor materials, bad contractors, or something deeper in the engineering process? The truth is, road failure rarely starts at the surface. It begins underneath. And today, we're breaking down modern road construction techniques layer by layer to understand what really determines whether a road survives decades or fails early. Because what you see is only 10% of the story. A road is not a single structure, it is a load distribution system. Every vehicle passing over it creates stress, and that stress must travel safely downward through multiple engineered layers. At the top, we have the asphalt surface. Below it, the base course. Under that, the subbase. And finally, the subgrade soil. If even one layer is poorly designed, the entire system weakens. Road durability is not about thickness alone, it's about structural balance. Before construction even begins, engineers study the soil, because the soil beneath the road, called the subgrade, carries the entire structural load. Through CBR testing, moisture analysis, and density checks, engineers determine whether the ground can handle millions of load repetitions. Weak soil leads to differential settlement, fatigue cracking, surface deformation. If the foundation is unstable, no asphalt layer can compensate for it. Strong roads always begin below the surface. Compaction is where strength is created. When soil is compacted, air voids are removed and particles interlock tightly. Higher density means higher load resistance. But here's the hidden risk. If moisture content is too high or too low during compaction, internal voids remain invisible. And under repeated traffic loading, those voids turn into structural weaknesses. Many roads don't fail because of bad asphalt. They fail because of poor compaction. Once the foundation is stable, structural layers are added. The subbase distributes loads and improves drainage. The base course provides structural strength and stiffness. Aggregate gradation here is critical. Too many fine particles trap water. Too many coarse particles reduce bonding. Precision at this stage determines how effectively the road resists heavy truck traffic. This is where engineering discipline truly matters. Now the surface material is prepared. Inside the asphalt plant, aggregates and bitumen are heated and mixed at precise temperatures, typically between 150 and 170 degrees Celsius. This is not just mixing stone and oil, it is controlled engineering chemistry. The type of bitumen selected depends on climate conditions, traffic intensity, load repetition. Temperature consistency during mixing is essential, because small deviations here can shorten pavement life significantly. The hot mix is transported and laid using a paver machine. Immediately after placement, vibratory rollers compact the surface. This window of time is critical. Asphalt must be compacted while still hot to achieve proper density. If compaction is delayed, density decreases. Lower density means more air voids, and more air voids mean faster oxidation, cracking, and deterioration. In road construction, timing is everything. But the greatest enemy of roads is water. When water enters pavement layers, it reduces shear strength and weakens internal bonding. Over time, this leads to stripping, where bitumen separates from aggregates. Eventually, the surface collapses. That's why proper drainage design is not optional. Camber, side drains, and subsurface drainage systems are essential for survival. Even the strongest pavement will fail if water is trapped inside. There are two major pavement systems. Flexible pavements distribute stress layer by layer. Rigid pavements, like concrete roads, distribute stress across a stiff slab. Flexible roads are economical and faster to build. Rigid roads last longer, but cost more initially. Choosing between them depends on traffic load, climate, maintenance strategy, and budget constraints. There is no universal solution, only calculated engineering decisions. The next time you drive on a smooth highway, remember, beneath your tires lies a carefully engineered structure. Strong soil stabilization, precise compaction, balanced aggregate gradation, temperature-controlled asphalt, efficient drainage systems. When roads are built correctly, you never notice them. But when shortcuts are taken, You feel every crack. Road construction is invisible engineering. And now, you understand what truly makes a road last.